Now let's face it, mechanical watches are complicated. And while that heightened level of complexity is a key part why we love these tiny little machines, it can also lead to important parts and aspects of watches being misunderstood even among more experienced collectors and enthusiasts. So in this video, what I wanted to do is shine some light on 8 commonly misunderstood watch parts and features to potentially broaden your understanding and appreciation for watchmaking as a whole. But also, say you're a little bit new to collecting watches, understanding watches, I would recommend a great jumping off point being in the description down below to our different parts of a watch article. This is more of a glossary of terms while also providing further understanding for different watch parts that I think are a great jumping off point as you're navigating this world of watches for the first time. Also have some great images on that blog to help call out specific features so that you know them in the future. So to begin our list, we have a feature that I think most are aware of, but fewer people totally understand its history and intended use case, the elapsed time bezel. Now, originally designed by Longines for pilots and navigational aid, the timing bezel cemented its place in history with the help of legendary dive watches, that original trio from 1953, namely the Blancpain 50 Fathoms, the Rolex Submariner, and the Zodiac Seawolf. One of the common descriptions of this feature you probably hear is how the bezel tells you how much air you have left in your tank during diving scenarios. Now that is at least partially correct, but more specifically, it really allows for an easy to use stopwatch feature. To use, align the 0 index on the bezel with the minute hand's current position, and then read the elapsed time from the graduated scale on the bezel. Before the advent of diving computers, the bezel was used to track bottom time, which is a crucial measurement not only for how long your air or breathing gas will last at a given depth, but also calculating the maximum amount of time you can stay at a given depth without risking diving injuries such as the bends. You'll also notice that many dive watches have additional finer markings on the first 15 minutes of the bezel. There is some controversy here, but this is generally understood to be intended for timing shorter events with greater accuracy, whether it's individual legs of underwater navigation or specific shorter periods of in-water decompression. In addition to its diving utility, the elapsed time bezel is also the world's simplest chronograph, providing one of the easiest ways to time daily tasks. And I know this is going to be the most basic of features on here that most people probably already know, but there are many that probably don't still. So since watches are a form of jewelry, when you hear the word jewel brought up for the first time in a horological context, you probably automatically assume its use of an aesthetic pursuit. However, despite being nice to look at, there is much more that goes with this small part, and it's actually crucial for the operation of these complex devices. To understand what jewels do inside a watch movement, it's important to remember that the movement in a mechanical watch is a machine with lots of moving metal parts that tend to rub and grind against one another, in the process creating friction that can wear down these components, adversely affecting the performance of the watch and ultimately shortening its functional life. Friction has long been an enemy in timekeeping, and from the earliest days of watchmaking, watchmakers did their best to mitigate its effects. One of the biggest discoveries was the development of jewel bearings that would have a small drilled point providing space for metal spindles that would allow free rotation of parts without as much metal on metal point of contact that would otherwise deteriorate components more quickly. There have been many precious and semi-precious stones used over the years, including rubies, quartz, and garnets, in some of the hardest wearing areas within watch movements. Now, when you turn your watch over, you see that exhibition case back, you'll see some of the visible jewels standing out with their typically red color. In the early 1900s, the innovation of flame fusion process enabled synthetic creation of rubies at a much wider scale, which has since become an industry standard. Jewels find themselves being used in a variety of different ways for watch movements, such as hole and cap jewels, roller jewels, and pallet jewels, all of which have their own important use cases and functionality. Moving from an actual component of a watch movement into an often misunderstood finishing technique, we're going to talk about bluing, which is traditionally achieved by heat treating parts such as hands or screws with an alcohol or gas lamp or electrical hot plate to create blue color. These components must be heated specifically around 280 to 300 degrees Celsius or 530 to 575 degrees Fahrenheit. If you've watched our video visiting JLC's manufacturer, you might recall us actually showing this technique in the restoration department in order to maintain the same end result of years prior when restoring a vintage timepiece. Now, when heated, the time the metal is exposed to heat directly leads to changes in color, starting from brown to purple and eventually to the desired blue. Apart from the changing color, this process also helps these parts with avoiding corrosion while also actually making the component itself harder. When you see blued components on a modern watch, it's important to note that the majority of bluing on less expensive watches comes from a chemical process or painting, which does change the color, but doesn't have any of the other benefits that come with actual thermal bluing. Moving into another finishing technique that provides more benefit than you might actually expect, we have anglage, also known as beveling. Now, this process involves using a series of tools along with a diamond paste to add a polished bevel to the side of bridges and other smaller movement components. Although there are some machines that can assist in less precise chamfering, the top tier anglage in the industry is absolutely beautiful and can only really be achieved by hand with a laborious process that starts with first cutting the 90-degree angle of the component down to a 45-degree angle before hand filing the edge with a wooden tool and diamond paste to achieve the polished look on the outer surface. When discussing with watchmakers and brands at a high level, they also will mention that beyond the eye-catching beauty of this technique, anglage also mitigates the possibility of debris from falling from cut edges of components into the movement itself. Diving into our final finishing technique, let's talk about guilloché, which is the machining of a watch component, most often a dial, using a special type of lathe. Guilloché in watchmaking dates back to the 1700s when it was intended to remove unwanted reflections from a watch dial surface by creating a number of different textures that would not shine light into the wearer's eyes and make reading the time difficult. Proper guilloché is not done through a pressing process, but either on a lathe by way of a rose engine that rotates or a straight line engine, with each being able to create numerous different patterns. The technique is done by an individual artisan that applies pressure from a cutter to a specific part that is going to be either rotating or moving in a vertical direction, depending on the type of machine. And with their other free hand, they'll have a wheel with a handle on it to allow them to have very meticulous ability to make these patterns. The different pattern techniques can be dictated by cams on the machine, with more intricate dials or parts taking hours to complete, a time where if only one small mistake is made, you will have to start over in many instances. While it's largely an aesthetic now, guilloché does still fulfill some of its intended purpose of limiting glare and reflections, while also looking simply stunning in the process. Moving away from finishing techniques and shifting into movement features, we have one of the most important parts of automatic watches that is rarely talked about, and that is a bridle. In the case of hand-wound watches, there is a point of resistance with the crown when the watch is on a full wind, so you know when to stop. Since automatic watches utilize a rotor to wind itself by way of our motion, the ability to wind the watch is basically infinite, which also means the potential for overwinding and damaging a watch's mainspring is a serious possibility. To combat this, automatic movements have what is known as a slipping bridle, which is a special pre-tensioned expansion spring that is connected to the end of the mainspring, the source of power for a mechanical watch. This additional spring at lower torque has enough grip inside the barrel to allow the mainspring to wind fully, but thanks to the bridle's preset torque range and special grease that is retained within a series of recessed areas inside the barrel wall, it allows the mainspring to slip or rotate inside the barrel when too much torque is applied. Once the mainspring is wound to a level of torque that exceeds the limit allowed by the slipping bridle, the bridle rotates within the barrel and safeguards your mainspring from coiling further. Although typically reserved for automatic watches, there are some hand-wound movements that also have a bridle style system. For example, Grand Seiko with their 9S64 that is housed within their popular SBGW collection of dress watches also has an ability to not be overwound even though it is a hand-winding movement. One of the leading ways to tell the health of your movement is through a thing called amplitude, another commonly misunderstood concept associated with mechanical watchmaking. It essentially measures the degree a watch balance wheel rotates in a particular direction for one beat. Amplitude is one of the leading indicators of how well your movement is transmitting energy down its gear train, as well, again, of indicating the general health of the caliber itself. As a rule of thumb, most modern mechanical watches are intended to ideally fall between 270 to 315 degrees or so when everything is working well. Some movements will have a quoted range of accepted amplitude by the manufacturer, and if it's a third-party movement, this can usually be found online with some ease. If amplitude is low, this shows poor efficiency and energy being distributed down the gear train and can be caused by a variety of different factors. To test this in your watch, you'll need a machine called a time grapher, which also provides a very specific picture of your watch's level of accuracy, amplitude, and beat error. Keep in mind that in order to accurately measure amplitude, you're going to need to know the lift angle of your watch movement, a number that is specific for different movements. It is also important to keep in mind that there's a range for amplitude, and calibers will have different acceptable ranges. In addition, small factors such as the way the watch is positioned, dial up, crown down, can also impact that rotation. Taking a look at our final misunderstood watch feature, we have the free-sprung balance. Now, this is a term that is thrown around a lot by brands, both big and small, and at the core of it, a free-sprung balance is a specific balance architecture type. On more inexpensive mechanical watch movements, you will most likely always see an index-regulated balance, which is to say that the effective length of the hairspring can be adjusted very slightly with a regulating organ. You'll usually see somewhere to turn a screw with a small plus and minus marking to know which way to adjust, or a small timing pin next to the balance spring. Now, a free-sprung balance simply means that the balance is of a fixed length and does not have a traditional regulating organ. Instead, it opts for using screws attached to the balance wheel itself. The effect of the weight and mass of the screws on the oscillating balance wheel can be changed adjusting the inertia of the balance and therefore timekeeping. Free-sprung balances are typically seen as a more premium solution in that they can be timed to a finer degree and are also less prone to the negative effects of shock. However, this comes at a cost, being much more expensive and are more involved to work with given their structure. But all right, guys, that is my list here looking at some different watch terms, features that are often misunderstood by many enthusiasts out there. If you enjoyed this video, maybe you learned something, please give this video a thumbs up. Really would appreciate that. It also does help out the channel. Be sure to subscribe as well if you want to stay up to date with future content. Definitely check out TeddyBaldassarre.com, full authorized dealer of 30 brands, quick and fast fulfillment, dedicated customer support, and a full factory warranty for all the products that we offer. How we're able to fund all of our productions here is through selling watches on our site on TeddyBaldassarre.com. So if you are in the market for a watch, we would love to have your business. We know you can buy a watch anywhere, but that allows us to keep doing what we're doing here, and we love what we do. But guys, thank you again so much for watching. Be well, and I will see you all very soon.